Hello everyone. For this tutorial video, I would like to demonstrate how to figure out the angles of more sophisticated triangles using the law of sines. If we were to split an isosceles or scalene triangle into two right triangles, we would pay attention to the angles at the tips of the two triangles that are opposite this split. We would see, because they are both opposite a common side, the side that we split at, their sine functions would have this split as a common factor, although their hypotenuses would be different. We next rearrange these formulas to see that the opposite side, the side we split at, is exactly equal to the hypotenuse of one of the right triangles we broke it down into, times the sine of the angle that we chose to study, i.e. the angle that is opposite the split. And because the height is a common factor in these two formulas, and it is in the same spot in these two formulas, the height is equal to both of these two things at the same time. And so, we can state that the two formulas are equal relative to each other, and then we would rewrite this formula in terms of fractions, so that sides and the angles opposite them are grouped with each other in a more organized fashion. So our formula now becomes hypotenuse of one triangle divided by sine of angle opposite it equals hypotenuse of the other triangle divided by sine of angle opposite that. We should next reiterate this process for a third angle, as we must prove explicitly that this works for all angles. So when we do, we end up with the same end result, namely that hypotenuse of one of the right triangles opposite sine of angle opposite that is equal to hypotenuse of other right triangle divided by sine of angle opposite that. Because in this formula, one of the sides and angles is the same as in the previous formula, owing to the simple fact there are only three sides and angles in a triangle, we can combine the two formulas we derived to prove our final answer, namely that each side divided by the sine of the angle opposite them are always equal to the other sides divided by the sine of the angle opposite them. And you can prove it works for right triangles too, because you can break them down into smaller right triangles in the same way you can break down complex triangles into right triangles. However, we must not mindlessly follow this formula, because we must remember the caveat related to inverse sine functions with regard to figuring out the degrees. So you must make a case-by-case judgment on whether the angle you get makes sense before you simply assume it is your final answer, usually via visual estimation, as it should be relatively obvious when you look at a degree whether it is large enough to warrant adding 180 to it. The other problematic thing about the law of sines is that by the way it is written, you can only work with it if you know one of the sides and one of the angles. However, if you do not, i.e. you only know one side and one angle and not both, you would have to use the law of cosines instead, which is what I will demonstrate how to use in the next tutorial video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.